So for now, like we are going to see how the response is going to be when I'm passing entire video as an input to this Onyx model. So yeah, I am getting the like after getting the detection from the model from the results, I am going to draw bounding boxes around the results, whatever it is being detected as healthy or as PPR. Yeah, and we are going to display the output. So this is the response of the previous run. Going to start. All the images are resized to 640 cross 640. Clearly, we can see that like the PPR is being identified, and we can see the PPR marks over here. There are some false positives as well. Mostly all the images in the video is like having PPR. I think I added one or two which are healthy. Clearly, we can see that the of the model is decently good as it is able to identify the PPR most of the time. The actual speed of the model is way more, which is like almost comparable to the speed of the video, but I have reduced the speed so that we can see what is happening. Yeah, in most of the cases, PPR is more. Yeah, the one healthy image that I was talking about. This is exactly how our model works when we are deploying it in our computer. Okay, now let's see about the Flask site or the user interface that we are going to have. The Flask site is actually going to run on the local host, so we can see the link. To just copy this link and paste it over here, and we're good to go. Yeah. So this is how our like homepage looks like. So we have whenever a disease is detected, it is going to be shown here. This is directly connected to the backend cloud where we are using ThinkSpeak right now. I'll show the structure of the cloud later on, and we also have a about page where we have briefly mentioned what exactly we are trying to do over here. So depending on the like number of diseases that are detected, the number of posts that are being created over here is going to keep on increasing. We have set it to an hourly basis so that like just in case if the system happens to detect the disease on one particular code, we won't have that entire spamming of our feed with the same code being repeated again and again. To avoid data redundancy, we have set a period of 1 hour, but for testing we have set it to 2 hours actually. We also have this option to register and log in into the account so that other people do not get access to this information about your farm. So let us try to create an account. And we can see that the account is being created, and we are back onto the home page and we can use our content. You can also log in account. We also have this like provision to create our own disease detection also in case the detection system is not functioning properly, so that we can eliminate in case of any errors are present. Now going to be showing about the cloud deployment where we have used ThinkSpeak. So this is the different diseases that have been detected. So this channel only monitors if a disease is detected or not. This is going to serve as the reference for the Flask site that we saw earlier. So the Flask site is actually reading data from here and like showing it to us, the end users. And this one is like general, generally all the data that is being collected periodically so that we can access it later on. That is what we have done here. So for uploading those data, so for uploading this data, I've taken some sample data over here. So based on the detection, and in case if any one of the value is one, that is, if any one of the disease has been detected, it is going to go to this. It is going to go to the link, and it is going to use our uh, right link of ThinkSpeak, and it is going to add this particular data onto the fields so that we can see the result outside. Let us try this with, yeah, anthrax in itself. So I'm passing this dummy input. Yeah, it is run. So let us see if it is reflecting there in ThinkSpeak. Clearly, the value that we have added has been reflected. So now, if we go back to our program, the Flask site, so the latest two are being displayed over here, 2 and 3. So we just added anthrax, and that's being displayed over here. You can view more diseases at the same time also. For now, we set the count to 2. For reading the data from ThinkSpeak, we are actually using this particular program's logic, where we are using the same link with the right API key, and I'm getting the response as a list. I'm converting it into a list, and I'm just adding it into the disease string, and I'm going to and I'm separating it by comma, so I can just display it as it is. List 1 of 0 is going to denote the like entry ID or the field ID, and the last one is going to show the created at. This is the format in which the data is stored at ThinkSpeak Cloud, and I'm using the same format because I'm aware of how the data is being stored. I'm using the indexing to display the result. So in the Flask site, this part will actually come in. Yes, it'll come over here. So this thing is happening beforehand, before our data is being displayed to us. So after that only, from here, the data is going to get collected, and it is saved into posts, and that post is passed as input to our home page. Through that data only, we are able to see the rendered view. And this thing is going to be the post input for the about page. The this data that we are viewing over here. This is exactly how our cloud connected with the Flash site. I was telling, right, how we can increase the number of diseases that is being shown to the end user in the Flask site. So I've set the result value here to be 100. Initially it was 2. So like right now we should be able to see the all the 3 diseases that were being logged. Let us check if it is working. Yeah. So like The same way, the initial disease that was detected was PPR, then anthrax, and anthrax. This was the one that was detected the latest. So it is working. So it started the MQTT protocol. Clearly, we can see the values are being sent through the connected IP address to the Raspberry Pi, which acts as the broker, mosquito broker. So these values are being displayed there as well. And I subscribed to the same channel, so I'm able to see the values here also. Strange. Clearly, we can see the values that have been recorded over there is being sent over here through the MQTT protocol. They sent periodically based on the references and Raspberry Pi. We are going to alter the things speak loud. Clearly, we can see even when we are running the same thing on Tony, we are getting the responses through the MQTT protocol in Raspberry Pi.